Good morning and welcome back to my channel, and today we are going to be finding the derivative of minus cos x. So let f of x be equal to minus cos x, you know the drill, then f of dash of x will be equal to, say it yourself, yeah that's right, minus cos of x plus h, plus cos x, because it's a double negative, all over h, and that should be the limit as h tends to 0. I know I should have written it on the left-hand side, but once again, I was a bit late thinking about that. So that will be equal to the limit as h tends to 0, not catching me out twice there, of minus cos x cos h plus sine x, sorry, it's minus sine x sine h plus cos x all over h. And then that will be equal to the limit as h tends to 0 of, I'm going to group these things up now, minus cos x times 1 minus h squared over 2. That's what cos h tends to when h becomes small. Plus cos x, this is what I mean by grouping them, plus sine x times h. That's just what sine h tends to when h becomes small. So sine h tends to h. All over h. And that will be equal to the limit as h tends to 0 of minus h squared over 2 times cos x. This one here and this cos x have cancelled because they're opposite in sign. A bit unfortunate use of language there, but you know what I mean, I hope. Comment below if you don't know what I mean. Right, let's get this started again. So cos x plus sine x h all over h. And this is where I can start my cancelling again. So I can take out a factor of h on the top by one of these h's here. So I'm going to take out a factor of h to the 1. Not as a power, just as a factor. And this h here, and I can cancel them with this h on the bottom. And so that will be equal to sine x if I evaluate my limit, which is true. So I know that sine x, to complete the loop, sine x differentiates to cos x, which differentiates to minus sine x, which differentiates to minus cos x, which differentiates all the way back to sine x, as we've just shown. Thank you for attending this video, and I look forward to seeing you all next time.